Today I would like to show you some filter tuning demonstration using CST Studio Suite and Filter Designer 3D. What we have on the screen here is a 3D model of a coaxial cavity filter with cross couplings that was designed in CST and optimized using Filter Designer 3D that is based on coupling matrix. And on the right hand side you can see the response, and this is perfectly tuned up passband with 2 transmission zeros on the high side. Now this model was manufactured. You can see the DUT standing here on my bench, and essentially if I now go to Filter Designer 3D, you can also see the response with the coupling matrix that was used to synthesize and optimize this particular model. So what I would like to do now is I have a VNA here, and you can see the measurements from this DUT. My laptop running Filter Designer 3D is plugged into this VNA, and so I am able to go and connect to this VNA. When I switch to the tuning tab, I say connect via the socket. You can see the results are automatically imported or read from the measurement equipment I have here, and this is a live real-time measurement. So when I tune some screws here on my filter, you can also see the response changing there. What I would like to show you next is the extracted error bar. So this is all the errors from my coupling matrix that is extracted via polynomial fitting, and you can see there some bars really that are large, and that just indicates that specific tuning screws need to be tuned to get a zero, to get towards a zero error, because essentially in the end we would like to reduce all the errors so that we can get to our desired response. So I'm just going to go ahead and do that. I'm just going to first work on my resonators, because those error bars are the largest, and I simply go in and tune it according to the bar that I can see live switching there as well. I can also see if so let's focus on resonator 1 here. The error bar, I'm just going to push it down by screwing the tuning screw in, and you can see it just dynamically going towards 0. You can also start seeing the S parameter response starting to come together, and so I'm just targeting the next error bars. You can see the highest error bar is also highlighted there. You can see it even highlighted in the topology. If we just maybe maximize here, you can see in the topology actually resonator 5 is highlighted and the corresponding error bar there. So it's very intuitive and interactive to tune. And so let's just go ahead and get this right down there, get the errors close to 0. I think we should be able to manage with about 1% error. Let's just go ahead. Now it gets very, very sensitive, but you can see the response nicely coming together. And let's see if we can get it to a nice equal ripple response. Now, what I also want to point out in this model is that we don't have tuning screws. If I switch back to CST Studio Suite and the model here, you can see the connectors there. I do not have a tuning screw for this particular connector, and therefore for the input ports, what we have implemented in Filter Designer 3D is also this so-called adapt return loss. So in other words, you can see the return loss in the end is not exactly at minus 20 dB, but it is compensated. It's compensating this coupling that I cannot control on the connectors, and therefore you still get your equal ripple response. You still get your passband with this compensation included. Now the great thing of this tool is you are designing in this tool, using this tool, and you're able to tune on the bench. So when you go into prototyping, you can easily give this to any person in the lab, give them a map of the tuning screws and the topology that you're using in FT3D, and they can simply target the extracted errors, and according to that tune up the entire filter in no time at all. So that's all from my side. If you want to know more, please go to 3ds.com.